Oh my gosh. Seeing this chalk everywhere. I'm so used to working with whiteboards now. All right, it's Professor J. I'm back. In this video, we're going to be dividing 4-digit by 1-digit numbers. Professor J has found a really cool website that gives the awesomest, the most awesomeness. I don't even know. I said that wrong, right? The most awesome, that's it. The most awesome, corny math jokes. Check it out. So, you know how we learned about triangles and angles this year. So, why is it that the obtuse triangle is angry all the time? Why is he always mad? He's mad all the time. Why is he mad? The obtuse triangle is mad because he's never right. Hey? You get it? He's never right? Okay, I know. I'm corny. Here we go. We got 4-digit by 1-digit numbers. I want to give you one with a remainder. Since I have this up from the last video, what I'm going to do is do the algorithm first, and then we'll use our strategy second, okay? So we have 5,637. We're going to divide that by 4. So if we set it up, we'll have 4 right here. 5,637 there. Then we'll say how many times does 4 go into 5. It goes in there 1 time. 4 times 1 gives me 4. I subtract, right? I divide it. How many equal groups 4 can I get out of 5? Just 1. Multiply. 4 times 1 gives me 4. I subtract. 5 minus 4 gives me 1. I check it. Yes, that's correct. I bring down the next number. 6. Boom. Got 6 here. That's 16. How many equal groups of 4 can I get in 16? It's going to be 4. 4 times 4 is 16. Don't mind the squeaking noise in the background. I think my neighbor's playing with his dog. Okay, so, but 16 minus 16, that's going to give me a 0. There's nothing left there. I'll bring down the next number, which in this case is going to be 3. That gives me a 3 there. Can I get any equal groups of 4 out of 3? No. Can't happen, right? So I'm going to actually put a 0 here. I don't just leave that blank. I still have to put that 0 as a placeholder, follow all the steps. So 4 times 0 is going to give me 0. That's the multiply. I subtract. 3 minus 0 is just going to give me that 3. And then I will check. Yes, that's correct. Bring down the next number, which in this case is a 7. Okay, so I have a 37 now here at the bottom. It might be kind of a little hard to see. But then I'll say, how many equal groups of 4 am I going to get in 37? Well, 36 is 4 times 9. That gives me 36. If I do 4 times 10, wait a minute. Can I do that? No, in division, I cannot do that, okay? So I can never do 4 times 10 when I'm using the algorithm method, okay? I only go up to 9, all right? So, and also, because what it's telling me is if I have to do 4 times 10, then I made a mistake somewhere earlier in my question, okay? When you're doing the algorithm. But in this case, 4 times 9 is correct. So 4 times the 9 will give me 36. I'll subtract, and I will get a 1. There's a 1. I'll put it right here. There's no other number to bring down. So this 1 that's left over is called a remainder. Okay, I have 1 as my remainder. So that means when I actually write the problem, I'll take this 1 that was left over and I put it here. I'll put remainder 1. So my answer was 1,409 with a remainder 1. Interesting fact, if you're one of those students that really likes to check your work and you understand that if I do the opposite operation, I can check the work, right? So if I take 1,409 and I multiply it times 4, it should give me this number. Well, that is true when you're working with numbers without remainders. But if you have a remainder and you want to check it by doing the opposite operation, you would do 1,409, you'd multiply it times 4, but then you would have to add that 1, okay? You have to add this remainder. Don't multiply it, it'll mess your problem up, okay? Add that 1. That's what you do. Remainder, guys, is just a leftover amount. So imagine if I had, we're done with this. Imagine, I'll just give a different example real quick. I had roses. I had 10 roses. And then I had, let's just say 4 flowers that were gonna go into each bouquet of roses, okay? I'm trying to see how many bouquets I can come up with, right? So I'll say, okay, well I got 10 here. You've seen that model before. I showed it to you in our first video we ever did last week. I would say, okay, I got 4 roses there, right? So that would be 10 minus 4, which gives me 6. Now I'd say, okay, well I got 4 more, right? So, okay, well that's another 4. I would have 2 left over. Now this 2 that's left over, they're still flowers, right? They're roses still, but are they bouquets of roses? No, because we said it took 4 to actually make a bouquet. So in this case, we would actually have 2 bouquets and we would have a remainder of 2 roses. That's what it would look like. That's where this remainder comes from. It's the leftover amount after you've split everything into equal groups. Okay, let's go ahead and talk about our the last thing. I wanted to talk about the same problem that we had up here just a minute ago. We're just going to use this strategy that we've practiced most of the year, that most of the students you guys are really familiar with, okay? So again, our number was 5, I'll just set it up right here. Make sure I give myself enough space because it's kind of a big number. 5,637, and we're dividing that by 4, okay? How many equal groups of 4 can we get out of this number? So we got to set up our partial quotient here, and then on the right of that, we'll set up our little guide, okay? Our T-chart. Got number of times, and then the number. Don't mind the chicken scratch. You know I write neater than that normally, but it's this chalkboard. It's getting me, man. It's getting me. All right, so I set this up here. Now I'm pretty much always going to use those first 2. I see this a large number, so I'm just going to go ahead and set the last one up here. Guys, remember, this does not change. This does not change, okay? You might have to, like on our last one, we might not need these here, but these numbers here, they're going to be the same every time, okay? It's just what we're multiplying this by. So now we'll set up our other side of our T-chart. 4 times 1 gives us 4. 4 times 2 gives us 8. 4 times 5 gives us 20. Okay? Then we multiply these by powers of 10. Again, like we did last week with our multiplication. So in that case, I would have actually 40 here. That's that times 10, right? And then I'll get 80 right there. And then I'll actually get 200 right here. We're nowhere near the actual total value, okay? So we definitely need to do this last one. So instead of a 40, this one, 4 times 100 is 400. 4 times 200 is going to be 800. And 4 times 500 is going to actually be 2,000, all right? Don't mind all this stuff over here, just projects and things that I've drawn little diagrams for and haven't got to them, okay? So now we got this all set up. We're all set up. We got our PQ that's going to go right here. We're ready to do our math. 4 times what over here gets me close to 5,000 without going over as I can get. Right there, 2,000. So we'll put 500 over here. We'll put the 2,000 right here. Subtract. I'll get 7, 3, 6, and that's going to be a 3 now. Okay, 3,637. Obviously, we'll have to do this again, right? So this is where I said, if you watched the last video, you saw I did not, for this one here, I did not cross this out just because I used it. Because as we can see, this number is still greater than 2,000. I could use it again, I'm going to. So I'm going to use it again. I'll have to put another 500 here. And then that'll be another 2,000 right here. I'll subtract. I'll get 7, 3, 6, 1. 1,637. So now that number is greater than this amount. So now I can get rid of it. I have an 800 though. Oh, check that out. 800. So I could do 200 here, and that would give me 800. Right away, I noticed that actually, look, this is for those advanced students again, so take a little pause. Check this out. If you've worked with me on this already, that's an 800. That's a 1600. So that were 1,600. That means really, instead of multiplying it times 200, I could probably multiply it times 400, and I would get 1,600 right here, and I could skip a step, okay? But again, if you haven't practiced that, you're not ready to do that, don't worry about it. We'll just use what we have here. So I have 4 times 200. I'll put the 200 here. That'll give me 800. I'll subtract there. That'll be a 7, a 3. I'll make that nice and pretty like that. And that's going to be an 8. I have 837. I can use this 800 again. So I'm going to do 200 one more time. It'll give me 800. I'll get a 37 left. Okay? So now I've gone through all these. I have a 37 left. What number is close to 37 without going over? Yeah, it's going to be that 5 right there. So I'm going to say 4 times 5, give me that 20. Okay, I'm going to put the 5 here, put the 20 right here. I'll subtract, I will get 17. All right, this is me. I ran out of space, so I'm just going to put a little arrow there. I'm going to come up here, keep going down here. So I have a 17 here. Okay, what number is close without going over? Now, I know all of these have been crossed out, because none of these I can use anymore. The number is so small, I'm up here. So really, if I wanted to, if it makes you feel better, get rid of all these so you know, hey, the number I'm dealing with, oh, it's even smaller than 20. All those are gone. The only options I have are the 1 and 2 now. So 4 times 2 will give me an 8. I'll subtract, there it is. I'll get this 9, right? And then I'll say, okay, gotta do this again. So I'll say 4 times 2 again will give me another 8. I'll subtract, I'll get 1. But I skipped a step. I should have put 2 here before I put that 8 there, right? So now I have all these numbers set up, and I have a 1 left over. None of these options are less than that 1, which means that 1 is a remainder. It's a leftover amount. Okay, so I'll just go ahead, add up my partial quotient. So I'll line this up, add it up. That's a 5, it's a 9 here. That's gonna be a 0 right there. And that's 10, 14. So I'll get 1,409, and I will not be done because I have this 1 that was here. It didn't factor in. It was a leftover amount. A leftover amount. So that is going to go right here, and it's still going to look like a remainder 1, just like so. And there we have it. Same answer we had before, 1,409, just like so. Again, if you guys have questions, I'm going to put the link to the question thing right below this. You guys can just write in the comments right here on YouTube if you want to. You still have contact with me, so reach out if you have a question or you need anything broken down. And next video we have for the week is going to be dividing by 10, 100, or 1,000.